Visible, no? So we completed with in the last class we completed with multiplexers, no? So today we'll start about the demultiplexer. So what is this demultiplexers? Okay. So we'll start about the demultiplexers. Okay. Demultiplexer. Okay. Demultiplexer. So demultiplexer it have single input, single input. Okay. N selection lines, N selection lines, and 2 power n outputs. Okay, 2 power n outputs. Okay, at a time any one of the input is connected to the output. Okay, at a time any one of the input is connected to the output. Okay, so here we can implement where you are using this DeMux. We can implement Boolean functions. We can implement the Boolean functions, or we can implement the combinational circuits. We can implement the combinational circuit by using DeMux. Okay, so how the DeMux will look like? So this is the DeMux. One second. This is DeMux. You have one input, okay, and two power n outputs, two power n outputs, okay. This is two power n outputs, and this is the these are the inputs, okay, and n selection lines, n selection. This is DeMux, DeMux, okay. Other name for DeMux is mm, data distributor, data distributor. Other name for DeMux is data distributor. Okay, this is about the DeMux. Okay, and next, this is about the DeMux. So I'll design this DeMux. Okay, first I will design 1x2 DeMux and next 1x4 DeMux. Okay, so if it is 1x2 DeMux, how many inputs and how many outputs are there? So 1x2 DeMux, 1x2 DeMux. So here you have one input and two outputs and one selection line. Okay, one selection line. So if you write the block diagram, the block diagram will look like this. So 1 is to 2 DeMux. Okay, 1 is to 2 DeMux. So here data input and two selection lines. Let us take y1 and y0, y0 and y1. These are the two inputs, and this is enable pin. Enable pin is acting like when enable equal to 0, it will be in whatever may be the selection line, you are getting the output as 0. When enable equal to 1 only, this will be activated. So enable selection line y1 and y0, y1 and y0. Okay, so you need to draw the truth table. So when enable equal to 0, whatever may be the selection line, you are getting the output as 0, 0. Okay, when enable equal to 1, when selection line is equal to 0, you are getting this is what D. Okay, y0 is connected to the input is connected to y0, and when enable equal to 1, when enable equal to 1 and selection line equal to 1, D input is connected to y1. Okay, this is 0. Okay, so from this I can get what is y0? Y0 equal to enable S bar and D. Okay, and this is y1. y1 equal to enable S D. Enable yes D. So next you need to draw the logic circuit. This is yes, and it is connected with an inverter. This is S bar. Okay, S bar, and one more input. Here I am taking enable, enable, and enable, and next this is D input, D input. Okay, so here what is why not enable S bar D? Enable S bar D. Enable S bar D. This is connected with AND gate. Okay. So y0 equal to enable S bar D. Okay. And next, y1 equal to what? Enable S and D. This is y1. Enable S D. Enable S D. Okay. So this is 1 is to 4 DeMux. Okay. Is this one 1 is to 2 DeMux? Any doubt in this? 1 is to 2 DeMux. You respond. Okay. And next you use. So this is 1 is to 2 DeMux. And next 1 is to 4 DeMux. So how to design 1 is to 4 DeMux? 1 is to 4 DeMux. You have how many inputs? One input. Okay. That is D. One input D. Okay. And next. 1 input D. And how many outputs you have? One input. One is to four. Four outputs. Four outputs. How many selection lines? Two selection lines. Okay, two selection lines. So if you see the basic block diagram, 1 is to 4 DeMux. How many inputs? One input and one selection, one enable pin, and four outputs. This is Y0, Y1, Y2, Y3. Okay. Next, you need to draw the truth table. Enable, enable, selection line S1, S0. Okay. Y0, Y1, Y2, Y3. 0, whatever may be the selection line, you are getting the output as what? 0. Okay. When enable pin is 1, selection line is 0, the data input is connected to Y0. Remaining all are 0. And when enable pin is 1, selection line is 0, 1, the data is pin is connected to Y1. When enable pin is 1, selection line is 1, 0, the data pin is connected to Y2. When enable pin is 1, 1, 1, the data line is pin is connected to Y3. Okay. From this you can get the expression. What is the so this one is anyway there, not there. This is y naught. Y naught equal to what? Y naught equal to E S1 bar S naught bar D. This is Y1 E 01 S1 bar S naught D. This is Y2 E S1 S naught bar D. Y3. Okay. Y3. Y3. Y3 equal to enable S1 S naught D. Okay. So from this you can draw the logic circuit. Okay. From this you can draw the logic circuit. Okay. First logic circuit. First you draw the D input, and this is S naught connected with an inverter. This is S naught next S1 connected with an S1. Okay. Inverter. Okay. And enable pin. Enable pin. Okay. So what is Y naught? What you got? Y naught equal to enable S1 bar S naught bar D no. So enable S1 bar S naught bar D. It is connected with an AND gate. This is Y naught. Y naught equal to what? Enable S1 bar S naught bar D. Okay. And next Y1. What is Y1? Enable S1 bar S naught bar S naught D. Okay. Uh, D is one input. 0 1. So 0 1 means S1 S naught bar and S1 and enable. Okay. So this is connected with an AND gate. This is Y1. Y1 equal to enable S1 bar. Okay. S1 bar. No? Okay, one second. S1 bar. Here you will get S1 bar, not this one. S1 bar S naught. S naught. S1 bar S naught and D. S1 bar, S0 and D. Okay. And similarly y2 equal to what? D. Okay. D S1 S0 bar. S1. This is S1 and S0 bar and enable pin. So enable pin. This is connected with the this is y2. Y2 equal to enable S1 S0 bar D. Okay. Y3. What is Y3? D S1 S0. This is S0 S1 and E connected with bit Y3 enable S1 S0 D S1 S0 D. This is 4 cross 4 marks. Okay. 1 cross 4 D marks. Okay. Is there any doubt in this? 1 cross 4 D marks. Should I move forward? Yes. Next. Next use. Next. How to implement DeMux. Okay. Implementation of higher order DeMux. Implementation of higher order DeMux. Higher order DeMux. Okay. How to implement higher order DeMux. Okay. Step 1. Step 1. Calculate the number of demuxes required. Calculate the number of demuxes required. Demuxes required by dividing higher order by lower order. Higher order with lower order. Lower order. Okay. Step 2. Continue till we get 1. Continue till we get 1. Okay. And add all the number of muxes. Step 3. Add add all the number of demuxes and connect. Add all the number of demuxes and connect. Okay. Suppose like if I want to implement for 1 cross 4 demux by using 1 cross 4 demux using this 1 cross 2 demux. Okay. How to implement? See here. Suppose if I want to implement, this is the steps to implement. I want to implement 1 cross 4 demux using 1 cross 2 demux. 1 cross 2 demux. Okay. How to implement? First, what I need to do? First, what is my first step? Calculate the number of demuxes required by dividing higher order with lower order. Okay. So, what is the higher order demux? What is the higher order demux? Here, higher order demux is 4. Okay. This is step 1. Step 1. Okay. So, 4 by 2. What you are getting? 2. Okay. So, 2 you will get in second stage, and 2 by 2, this is equal to 1, you will get in first stage. You will get in first stage. Okay. So how I can design? So here, so this is first stage. First stage, you have 1 demux. Okay. So 1 is to 2 demux. 1 is to demux. This is D input. Okay. And you have two outputs, y0 and y1. Okay. These are acting as a data input for these two demux. In second stage, you have uh, second stage, you have two demux, 1 is to 2 demux, and this is 1 is to 2 demux. Okay. And y0 is connected as a data pin for this one, and y1 is connected as a data pin for this one. Okay. And Selection line. Here, what is the selection line? Yes, sir. Let us take the selection line is what? Yes, one. Okay. And here, what is the selection line? Let us take the selection line. Yes, sir. So common selection line will be there. Okay. Common selection line. Yes, sir. This is yes not. Yes not. Okay. Enable pin is common. So here, this is enable pin. Enable pin is common for these two muxes. Okay. Here you can give one enable pin. Okay, this is one enable pin, and next you can give this common enable pin. Okay, so how many outputs are there? Y0, Y1, two outputs. Okay, uh, Y0, Y1, and this is also Y0, Y1. Okay, these are the outputs of D 1 cross 2 DeMux. So here you'll get the output, four output, Y0, Y1, and Y2 and Y3. Y2 and Y3. Like this you can implement. Okay. One more implementation is like suppose so you should use two cross one cross two demux, two one cross two demux. So this is one cross two demux, another one cross two demux. Okay. Uh, so common data line will be given. So this is the common data line, data input for two demux. Okay. Common data input is given. Common data input. This is D input. Okay. So selection line. This is selection line. This is S naught, S naught. Okay. So S naught is common for these two. Okay. This is S. Okay. S naught is common. Whereas S1 is there, no? S1, S1 you are giving through the enable pin. Okay. S1 you are giving through the enable pin. Okay. So how you are giving here? This is S1. You are giving through an inverter. Okay. Through an inverter I am giving. Okay. Here S1 I am giving, and this is given to enable pin. Okay. So how we can analyze means here we already seen the truth table for 1 cross 4 DeMux. Okay, 1 cross 4 DeMux. So how many lines you will get? This is Y0, Y1, and Y2 and Y3. Okay. So we already seen the truth table. No, that is S1, S0. Next Y0, Y1, Y2, Y3. 0 0. When it is 0 0, data pin is connected, data line is connected to Y0. 0 1, data line is connected to Y1, and 1 0, data line is connected to Y2. 1 1, data line is connected to Y3. Okay. So see here, just you divide into two equal parts. Here what this is what S1 equal to 0. Here S1 equal to 1. Okay. So when S1 equal to 0, which mux will be activated? When S1 equal to 0, here you are getting 1. Here you are getting 0. So this mux will be activated. This sorry, this demux will be activated, and this mux will be deactivated. Okay. You are getting what the data input is connected to either Y0 or Y1. Data input is connected to either Y0 or Y1. Okay. And next you see. Suppose suppose okay. What, 0. This becomes what? This becomes 0. Okay. This becomes 0, and this becomes what? 1. This becomes 1. Now when in S1 equal to 1, this will be activated. This demux will be activated. This demux will be deactivated. Why? Because you are given to what? Enable pin. Given to enable pin. So that means this is activated means what outputs you are getting? Y2 and Y3 you are getting. So that means here in this when S1 equal to 1, you are getting this y2 and y1. Okay, y2 and okay. Yes. Not visible. Okay, sorry. Okay. Now it's visible. Your response. Okay. Yes. Yes. So this is about like I explained how to represent 1 cross 4 DeMux by using 1 cross 4 DeMux by using two cross 4 DeMux and selection line is given directly to 1 cross 2 DeMux and this selection line S1 is given through the inverter and it is given to the enable pin. So when S1 equal to 0, you are getting the two outputs Y0 and Y1 and when S1 equal to 1, you are getting the two outputs Y2 and Y3. Okay. Is it fine? Do you understood any doubt in this? Your response. So that will move forward. Okay. Next step. Suppose if I want to implement 1 is to 8 DeMux, 1 is to 8 DeMux using 1 is to 4, 1 is to 2 DeMux, 1 is to 2 DeMux. How to implement? Okay. How to implement? We'll see. Okay. 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 So, how to implement the steps you need to follow? What are the steps? Step one, you need to divide what? Divide 8 by 2. 8 by 2. What is the quotient? 4. So, this will come in which stage? Third stage. Second stage. Sorry, second stage. Okay, second stage. One second. This is implementing a 1 is to 4 DeMux. Okay, let us take 1 is to 4 DeMux. Okay, implement 1 is to 4 DeMux means what? Divided by 4 means this divided by 2. This comes in which stage means you are getting in second stage. This you will get in second stage. Okay, I'm implementing 1 is to 8 DeMux using 1 is to 4 DeMux. Okay, again 4 by 2 by 4. No, 2 by 4 means you are getting 0.5. So in first stage, what I am doing? I'm using 1 is to 2 DeMux. First stage, I'm using 1 is to 2 DeMux. Okay. So how to implement first stage? This is stage 1. First stage, I'm using which DeMux? 1 is to 2 DeMux. No. So this is 1 is to 2 DeMux. So 1 is to 2 DeMux. 1 is to 2 DeMux. This is data input. Okay. And uh, so 2 1 is to 4 DeMux are there. 2 1 is to 4 DeMux are there. 1 is to 4 DeMux. These two, you are getting Y0 and Y1, no? Y0 and Y1. These we are using as a data lines for this one. Data lines for this one. Okay. Common selection line. That means for 1 is to 8 DMux, how many selection lines are there? 3 selection lines are there. And for 1 is to 4 DMux, you are having 2 selection lines. Okay. So 3 selection lines, those are nothing but S0, S1, and S2. Okay. So 2 selection lines I'm giving like this. Okay, this is what S1 and this is S0. Okay, and this one, one second, it's not S1, this is S2. This is S2. Okay, and how many outputs? 4 outputs. Each DMux, so you will get 4 outputs: Y0, Y1, Y2, Y3, Y4, Y5, Y6, and Y7. So like this we can implement. Okay. So next to for DeMux, whatever this next to DeMux is there, you can replace with the inverter also. So here if you see, so I'm using two 1 is to 4 DeMux. This is 1 is to 4 DeMux. This is 1 is to 4 DeMux. Okay. Let us take D input. This is D input. Okay. D input, common D input. Common D input. And so what are the selection lines? S1 and S0 are common. S1 and S0. Okay? These are common selection lines. S0, this is S0, S1 and S1. These are common selection lines. Okay. Let us take these are given to B, and next these are given to C, B, C. Okay. And uh, next this one I'm giving through the inverter. This one I'm giving through the inverter. So let us take this is A, and I'm giving this one. How many outputs you will get? Y naught, Y1, Y2, Y3. Next, Y4, Y5, Y6, Y7. Okay. So that means you can analyze like this. That means how many selection lines H2, S1, and S0, no? S2, S1, and S0. So let us consider this is what this is another pin. S2 equal to what S1 and S0. This is what selection lines you given as A, B, C. So three inputs are there. How many possible combinations you have? Eight possible combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. So here in this y1 equal to 0, and y1 equal to b. Okay. y3 equal y2 equal to b. Okay. And y3 equal to b, and y4 equal to d. Those are 0 only. Y5 equal to d, and y6 equal to d, and y7 equal to d. Okay. So if you divide, see here, if you divide, so this H2 is there, no? This decides what outputs you need to get. See here. So when that means H2, that is A. When A equal to 0, this is what 1, and this becomes 0. This becomes 0. So during when A equal to 0, this DeMux will be in active state. Why? Because it is given to enable pin. Okay, and this DeMux will be what inactive state. This will be inactive state. So what happens? Only these outputs you will get. Y naught to Y1. Depending on that means which one will decide. So depending on this selection length, when it is 0, 0, this one is connected to Y naught. Okay, 0, 1. This the input is connected to Y1. 1, 0, which is connected. The input is connected to Y2, and 1, 1. 1, 1 means what? Y3 is connected. It is connected to Y3. Yes. Okay. And next, suppose suppose if a equal to what? 1. A equal to 1. This becomes what? 0, no? This becomes 0. Okay. This becomes 0, and this becomes 1. Okay. This becomes 1. So in this situation, this will be deactivated and this will be activated. Okay. This will be activated. What happens in this situation? A equal to 1. You are getting these outputs. Okay. These outputs will be in invalid state. Okay, and this will decide when it is 0, 0, this data input is connected to Y4. You are getting Y4. Okay. And 0, 1, you are getting Y5. 1, 0, Y6. 1, 1, Y7. Like this you are getting. Okay. So like this you can implement the DeMux. Okay. Like this you can implement the DeMux. What are the applications of DeMux? We'll see. Suppose what are the applications of DeMux? Okay. So applications of DeMux, if you see, in Mux also we already seen no applications of DeMux. Suppose if you take the single source, okay, single source maybe you can take personal computer or laptop, personal computer or laptop. Here this is we can call as selector, or we can call as data distributor. Okay, selector or data distributor. So this one is a DeMux. Okay. Uh, so From this PC or laptop, I'm giving a data input, D input. Okay. This is a 1 is to, let us take 1 is to 4 DeMux. 1 is to 4 DeMux. Okay. So multiple destinations, multiple destinations, multiple destinations. I can connect to black and white printer. I can connect to fax machine, fax machine. I can connect to color inkjet printer. I can connect to pen plotter. Okay. So these are nothing but different four inputs D0, D1, D2, and D3. So I can connect to black and white printer. D1 is connected to fax machine, and this one is connected to color inkjet printer, and D3 is connected to pen plotter. Okay. So depending on the selection line, you have two selection lines, B and A. Okay. So depends on this 0, 0. This PC is connected to D0, which is connected, which is selected. This is select the destination. You need to select the destination. Okay. So it will select a black and white laser printer. Okay. 0, 1. It will select fax machine. Okay, fax machine, and 1, 0, it will select color inkjet printer, and 1, 1, it will select pen plotter, pen plotter. Okay, so like this we can design the DeMux demultiplexer. Okay, demultiplexer is nothing but what we are seeing today. So we are seeing what is DeMux. Okay, first we are seeing about this one. What is DeMux? DeMux is nothing but single input, two foreign outputs and then selection lines. We can implement Boolean function or combinational circuit. This is the block diagram. Explain the 1 is to 2 DeMux, one input, two outputs and one selection line. And 1 is to 4 DeMux, one input, four outputs and two selection lines. Okay. Here you have two selection lines. Okay. Here you have two selection lines. Let us take the selection lines are S1 is MSB pick, no? S1 and S0. S0 is LSB, okay? And this is the logic circuit, okay? Implementation of higher order DeMux by lower order DeMux means these are the steps. First quotient you will get in second stage, second quotient you will get in first stage, okay? With inverter also I can implement, okay? With the two table I analyzed. This we designed 1 is to 8 DeMux by using 1 is to 4 DeMux. So first stage I'm using 1 is to 2 DeMux, and second stage I'm using 2 1 is to 4 DeMux. So common selection lines for this one, and this is separate selection line. And this is with the in the place of this 1 is to 2 DeMux, so I can replace the inverter also. Okay. So this is the application of the DeMux. Okay. These notes I will share you.